itu orang lain tolong rekodkan. Saya tak
Tak
keluar
percaya
daripada
rekodkan.
skrin. Okay, thank you. And back to our discussion just now, for this paper, actually, kalau you had two references, the researchers did on analysis by doing numerical simulations. So taking from the related information from this newspaper or from any published articles, and some forensic team went to the site area and they did some investigation, and in order to know what were the main causes to the problem, they had doing on the numerical simulations by some assumptions and some parameters obtained from the site area. Then they can analyze what were the main reasons behind the collapsed building. So, and you can see here, the workers were working on the construction for the underground garage. During the time, there were many construction activity happen at the same time. So, not knowing that the construction activities created at the time has given additional stresses to the soil. So when this thing happened without notice, the building has started to collapse. So the consequential results, authorities organized the rescue work. Moreover, according to the online real estate data, sales have been suspended due to this problem. So we break 5 minutes while Azan finish. Okay, so we are back to discuss our case description for the problem building collapse in Shanghai. So apa yang berlaku bila ada laporan mengatakan bangunan ni tumbang, so automatically dia menyebabkan construction terhenti seketika dan memberi impact kepada ekonomi lah. Maknanya yang dah booking beli bangunan pun tarik daripada nak teruskan bayaran. So ini memberikan impact lah kepada pihak company tersebut dan juga authority. So after the incident, the relevant departments opened the external advisory, which talked to around 200 people and 400 property owners have completed the return registration form. So ini yang berlaku lah apabila bangunan yang kita dah book untuk kita duduki tetapi failure kan. Contoh kalau macam my personal opinion lah, kalau saya nampak lah ada future development nak bangun lah kan. So as part as the person yang memang involved in the soil, walaupun saya bukanlah salesperson untuk construction, untuk projek-projek perumahan, saya akan siasat dulu lah kan tanah tu jenis apa, kemudian kawasan tu dekat tak dengan sungai, so ada history tak nak beli rumah dekat area tu, ada history tak kawasan tu pernah banjir. So ini pun menjadi salah satu point bila sales hartanah meletakkan satu kriteria ataupun dia letaklah okey rumah bebas banjir. So maknanya harga rumah tu mungkin mahal. Kalau kata rumah terkesan dengan banjir, nilai rumah tu pun mungkin murah. So pandangan saya macam itulah. So dekat depan UiTM, for example, my personal opinion pun dia ada letak satu iklan board lah nak jual rumah apartment. But since I was here in 5 years, and then kita sendiri as a local resident dah pernah nampak kawasan tu pernah banjir. Jadi bila developer letak dia punya iklan nak buat bangunan, so kita dah start thinking, is it safe our building? Walaupun rumah kita nanti kalau dibuat apartment, selalunya dekat bahagian bawah tu dia akan letak car park. So rumah dekat bahagian atas, possibility nampak macam selamat, tapi kita tak nampak below the ground ataupun basement ataupun piling itself. So piling macam mana pun dia takkan bila datang air selalunya kalah lah. So my opinion to you, if you have ada extra money and then you want to buy a new house or whatever it is, please do detail investigations on this part. Adakah kawasan rumah tu dekat dengan sungai? So for example macam Shah Alam 2 tahun lepas atau 3 tahun lepas yang banjir teruk tu pun salah satu punca kan yang never expected dalam dekat section 25 yang boleh nak berlaku banjir besar. So, bila banjir dah berlaku, lepas tu barulah datang this expert person, okay, dia buka balik sejarah lama. So that's the process forensic. So maksudnya dia buka balik, dia study, dia tengok balik, oh past record rupanya ada laluan sungai. Tapi laluan sungai ni dah tertutup sebabkan ada constructions. So these some things that as a buyer, kita kena tengok lah our money value tu sesuai tak kita nak letak duit kita pada rumah yang macam tu. For this case pun sama, bila kata buyer ni dah dalam duit, tiba-tiba berlaku ni collapse one of this building, dia pun tarik kan ada punya pembelian tu because of this thing happen. And in future, for example lah, kalau kata they resist to maintain the buying of building tu, tapi kita dah nampak the Diampu River very close to the site area. So maknanya kata akan ada masalah yang berulang lah untuk this kind of the area. For me is that bila collapse building ni berlaku sebelumnya residential datang duduk, itu satu good signs lah because dia tak melibatkan kehilangan nyawa, just only cause for the structure damage only kan. So ada benda yang bagus lah. So bila forensic did their work, baru kita nampak banyak faktor yang contribute to the failure. For example here, the Diampu River flood and inaccuracy when building prevention control wall, which could not prevent the accidents. And then bila dia buat detailed investigation results, further inspections and prevention work has been done to accident site. After detailed inspection, it was determined that the nearby buildings are in compliance with the safety standards. 120 temporarily evacuated residents have returned home. Ini ini yang pihak let's say kita kata public authority or any other persons that di bahagian luar yang mengatakan the construction is not following to the standard. Of course, the owner of the building ataupun developer will say that they follow the standard. But then bila datangnya the expert engineer team ni from structural, geotechnical dan diorang buat balik numerical simulations, they found out from the site investigation itself, bila dia tengok balik macam mana failure mechanism on the structure pile, so dia dah boleh create that it's not something yang tak follow to standard, tetapi ada lagi faktor-faktor lain yang menyebabkan failure kepada bangunan tu berlaku. Okay, this is how it was started on 27 June 2009. The building founded on pre-tension span high strength concrete piles collapsed in Shanghai, China. Prior to collapse, an underground garage was excavated to the soil of the building, while excavated soil was dumped to its north side and formed a 10-meter high field slope. Maknanya dalam fenomena ni, dekat bahagian depan utara tu, bahagian utara bangunan tu ada selonggok tanah daripada excavation process, dia pelonggok tanah dekat bahagian utara bangunan. Dekat bahagian selatan pada waktu yang sama, mereka tengah buat excavations untuk start the underground basement. So bila yang ni berlaku, maknanya akan create some lateral stresses, kemudian akan berlakunya soil movement, and during the time dia tak provide retaining wall. So apa yang kita boleh highlight kat sini in the simple or any other reported news regarding this problem. So from different perspective point of view, so the collapse was due to rotating or overturning and falling on its sides. So the collapse is due to the soil and foundation instability problem that was induced by transported soil from the excavation work. Maknanya bila forensic investigations or we did the back analysis, so they can have many thoughts. From this group of researchers, they said this one. From these other groups of researchers, they said this one. But again, they will having different thoughts and results based on the process of analysis and the process of gathering data. Kalau banyak data yang you ada, and then you know how to analyze it, and you know how to perform the analysis using this data, you can have huge results and you can have a lot of discussions that bring to the final one. But again here, in the short discussions or conclusion, it says that the failure mechanism of the building due to the overturning and falling on its sides. And tambahan pula ada dua aktiviti yang berlaku pada ketika waktu berlakunya collapse building ataupun failure tersebut. Okay, just to recap, because saya rasa most of the my students here memang working experience pun very good and long in industry. Kemudian just to recap, what is a PHC ataupun pre-tension span high strength concrete piles. So kalau ikutkan the sources, so this PHC is very economical deep foundation system, superior quality and consistency compared to conventional cast in situ ataupun precast concrete piles. So these piles have a hollow section with an outer diameter ranging from 300 to 1,200. Maknanya it's a high strength concrete. Supposedly dia selamat. Maknanya kalau dia nak guna untuk deep foundation pun dia takkan ada masalah. 13 tingkat bangunan tu sampai boleh support. Supposedly from our assumption and understanding begitu. Okay, that's coming to the investigation. So, kenapa dia tak berlaku as what we expected. So from here also, the pre-tension span high strength concrete has been widely used in building foundations in many parts of the world owing to the advantages of high acid bearing capacity and standardized manufacturing process, well-controlled product quality and outstanding economic benefits. Maknanya sebelum dia nak gunakan untuk buat bangunan tu, maknanya dia dah melalui quality standard. Atau kita boleh assume lah the failure also can occur if they say that not following to the standard during the constructions, installing the piling or in any other things that related to it. Meaning that before nak install, before nak penetrate or deep pile into the ground, so ada some cases soil perlukan treatment ataupun improvement. So these are the things yang mana mungkin not following to the construction standard. Okay, some advantages kalau kita tengok from just now, it's very economical, kemudian efficiency, and it's allow for longer span. The concrete members offer more resistance against shear force. So these are the reasons why, because it has resistance to the shear force. Pre-stressing can reduce the volume of concrete required in construction, lowering the use and transportations of material, as well as boosting durability and service life. What are disadvantages? So it is more costlier, need more skill level for designing parts, unable to extend them if needed, more difficult to transport because of their heavy load. So inilah kalau benda tu bagus, dia mungkin ada kelemahan. Okay, talking about the constructions, ini yang as reported. So the site condition before the collapse of the building. So prior to the collapse of the buildings were supported by hollow concrete parts. So just now PHC tu. So ini keadaan asal dia. So during the construction, an excavation on the south side of the collapsed building was ongoing for an underground garage. So the excavation for the garage was dealt to a depth of 15 feet ataupun 4.572 meter lah. The excavated soil then was stockpiled on the north side of the collapsed building to a height of 10 meter above the existing ground elevation. Maknanya dia dah excavate kat belah selatan, kemudian dia pi humban lah ataupun dia pi letak dekat bahagian utara. So ini dia punya gambar rajah lah dekat bahagian kanan kat sini. Proses excavation dekat bahagian selatan bangunan, bahagian utara ni tanah-tanah yang dia korek tu dia pergi letak dekat bahagian depan bangunan tersebut. Okay, ini adalah locations ataupun the plan view of the construction site. So remember just now from the case description, the site is very close to Dimpu River. Kemudian this is the contour of the area, and also this is our suspected collapsed building number 7. And here is the distance of the building. Okay, excavated to formation level, plain concrete layer completed. So the Shanghai is located at the estuary of Yangtze River Delta along the coast of the East China Sea. So the geology is mainly composed of alluvial and marine sediment deposited during the Quaternary period as a result of pretty warm and cold climates and sea level changes. So these are the risiko bila kita having a construction site yang mana soil material ataupun soil foundations is having some kind of the problematic soil or soft soil. For example here, of alluvial and marine sediments. Maksudnya kalau kita ada jenis tanah, ada tanah tu coming from 3 different panel rocks, sama ada granite, metamorphic ataupun sedimentary. So this kind of the sedimentary, kalau you look at to the sizes ataupun the material itself is very loose lah. So this kind of the marine sediment ni kalau ikutkan they can have some sand, gravel, kalau dia can be also has silt and also clay. So bila alluvial and marine sediment ni is deposited, maknanya the process transportations of soil from one place to another place with the weathering agent. So maknanya the chances to have this kind of the soil erosions adalah tinggi. So kenapa this statement came here? Because they did the investigation. They want to know the history of the site. So they did on geological study and they found out that area is very close and the origins of the site itself from the alluvial and marine sediments. So the alluvial and marine sediments is very for me that kalau kita tengok dari segi strength tanah tu they're not good. Maknanya kalau kita kategorikan antara rock, kemudian silt, clay, in between tu adalah sand, maknanya okay lagi lah berbanding sand and berbanding clay dengan silt. Tapi bila this kind of the sediment ni, the high chances adanya erosion tu boleh terjadi. So bila ada this kind of the informations, it's very important on part of the geological and also geologists to relate what are the factor or causes brings to the collapsed building. Is it due to erosions? Is it due to the high water table? Is it due to the structural failure, or many things? The failure for here, in the different words, it says that the rare foundation failure and collapse of the building in China was caused by excavated earth on one side and pile-up earth and water table on the other sides, so exerting differential pressure on the piles. So this is what one of our friends said just now. So the mud pile up to a height of 10 meters on the north side of the building and the excavations of 4.6 meter. Maknanya dia ada different elevations. On the north is a 10 meter and then excavation dalam 4.6 meter dalam lah. So the collapse was due to rotating. This is again and caused by transported soil and weak foundation from the excavation work. Okay, if you look at to this schematic diagram showing to you the original conditions before collapse happened, collapse took place, and these are the process from the beginning to end. So if you look at here, 13 story building ni dekat sebabkan dia bangunan tinggi, high-rise building, kemudian kedalaman dia more than 3 meter, so kita pakai pile foundation. So it's not suitable to use the shallow foundation. As remember last class, untuk one case study, triangular grain elevator, case study tu dia menggunakan mat foundations. So mat foundation kat sini, dalam case tu, dia punya kedalaman embedded depth not more than 3 meter. But here, excavation lebih daripada 3 meter, dan for high-rise building, they need the pile lah. And the figure number 2, the plan called for underground garage to be dug out. The excavated soil was piled up on the other sides. So at the time, heavy rainfall and the water seeping into the ground. And the next figure, the building began to shift and the concrete piles snapped due to the uneven lateral pressures. And the next in figure E, it shows that the building started to tilt and finally is collapsed. Same meaning but different schematic. Ini yang didapati lah. So all these pictures were taken from the case article reported by the researchers. So you can see closely from the left top and to the right and also at the bottom. So this is the existing building not suspected to collapse. Ini bangunan yang dah collapse. So you akan nampak lah span pile ni dia dah split dia dah patah. Kat sini pun nampak. Dekat bahagian bawah lain pun nampak juga lah. So kalau you nampak kat sini the hollow span pile and inside it dia ada some deep mixing lah untuk proses strengthen. Okay, the problem. So we started to investigate apa punca dia. One of it is due to heavy rainfall. It was reported also the river Dampu flooded the nearest 70 meters of landslide flowing over the flood prevention control wall. So the local government arranged rescue work. So this is as reported again. So the area was located at the Dampu River source bank. The workers were busy with underground garage construction at the time. So cracks on the flood prevention wall near the building as well as the special geological conditions in the water bank area. So all these problems are related to each other, daripada hujannya, lepas tu history of the site, geological conditions dia, kemudian the relates with the soil foundations, and it also coming to the problem with the structural integrity, and the weight of the pile created a pressure differential which led to shift in the soil structure, eventually weakening the foundation and causing them to failure. So maksudnya bila ada problem soil structure interactions, so kita tak fokus kepada one material only ataupun kita tak fokus problem tu pada soil. Kita kena tengok problem berkaitan dengan structure. So kalau soil structure can get along together, so the structure should be safe. Tapi kalau kata we not doing the simulation, kita tak try dengan simulation, kita tak predict what will happen. So benda yang kita tak predict dengan simulation boleh berlaku. So sometimes simulations is very good because it can give you some predictions, something that you cannot see in future. But again, the things when you deal with the simulations or numerical modelings, the important part is the key parameters input materials and what are the material behavior that you may want to get in the simulation process. Because if we set wrong assumptions, that can give you wrong results. So in this problem, as I said again, if you have some skill on the numerical simulations, whatever design or project you have, you can start doing the simulations first. Let's say if we have this kind of the hypothesis, what if this stresses increase? What if this the construction stages change from A to B, for example? What will happen? Let's say we not having the numerical simulations, we do not have the predictions earlier. We just rely on what's analytical design analysis and calculations. We couldn't see these things, but with the help of the geotechnical modeling, it can give you a different perspective in part of your design and also the analysis. Okay, just now we look at to the problem now with details in the causes of the problems. Again, here is the due to the pressure difference on two sides of the structure is very seen from the north and from the south side. Improper construction methods are believed to be a reason of the building collapse in Shanghai. So the investigation teams report the workers stuck an underground garage on one side of the building while the other side was heaped up to 10-meter high, which was apparently an error in constructions. So this might be followed to standard. Maybe they had set the height for excavations or for the embankment not more 10 meter. The cracks on the flood prevention wall near the building can be seen. The special geological conditions in the water bank area. The accident was due to construction company ignorance, and the design of building material is okay. This is what they say. The collapse was caused by earth excavated along the building on one side with a depth of 4.6 meter for an underground car park and piled up to depth of 10 meter on the other side of the structure. So the wave of overburdened earth created a pressure differential, which led to a shift in the soil structure, eventually weakening the foundation and causing them to fail untrue for devastated failure. So the thing is that from point first to the last point, it has connections. So we can conclude that due to the pressure difference on the north and the south side. In part of the technical sounds. So in summary, what we can say that an excavation for underground garage was made on the south side to a depth of 4 meter without any support for earthfall. So the excavated earth was piled up on the north side to a height of 10 meter. So the building experienced an even lateral pressure from south and north. So this was due to the overburden pressure and erosions of soil in the pit adjacent to the building as a result of heavy rain. So this resulted in lateral pressure of 3,000 tons, which was greater than the capacity of the concrete pass. So the building toppled over in the southerly directions. So then conclude yang mana lateral pressure sebanyak 3 tan lah. Okay, the theoretical. So actually teori ni saya just recap in the short notes. I mean that kalau you feel that nota ni tak mencukupi, so please take your time to get info on this part. So talking about the foundations, as I said, when you do the analysis, first you need to know the theoretical background, and then you need to know also the soil characteristic, the soil parameters. Is it your foundations lay on the silt clay, or is it your foundation lay on sand? Because everything's on different soil characteristic to give you different theory and also formula. Some things, the formula can be modified accordingly to the conditions or to the factors. For example, the stress, overburden, and also to the shake factor or depth factor or etc. For here, for example, for the pile classifications, the thing is that if you have excavations more than 3 meter, you can go straight forward to the deep foundations, or you're not excavated to the 3 meter, but the soil conditions is very weak. Therefore, you can opt to the deep foundations. And deep foundations ataupun lain tu kita boleh sebut pile lah, pile foundations. Pile ni part of the mechanism to carry the load dia berbeza. Ada pile yang kita panggil sebagai end bearing pile, ada pile dia sekadar shaft pile, ada pile dia can combine, iaitu end bearing shaft pile. So setiap pile ni different capacity. Maknanya ultimate bearing capacity dia berbeza. So ultimate bearing capacity pile, ultimate bearing capacity for structure itself. So there are different things. So untuk this part, kalau formula yang saya tunjuk tu lebih kepada formula pile capacity lah in part of the geotechnical design. So saya rasa kalau daripada JKR selalunya dia akan ada lah formula untuk pile capacity yang structure, kemudian pile capacity untuk soil. Okay, the function to transmit foundation loads through soil strata of low bearing capacity to deeper soil or rock strata having a high bearing capacity, or used in a normal ground condition to resist heavy uplift forces, or in poor soil condition to resist horizontal loads. So ini adalah fungsi pile. When use pile foundations, when you have inadequate bearing capacity of shallow foundations to prevent uplift forces and also to reduce excessive settlement. Okay, pile can be categorized into construction, for example, ataupun load bearing, load carrying. Kalau case ni based on the construction kan, sama ada displacement pile ataupun non-displacement pile. And kalau you tengok sini, displacement pile pula dia ada dua kategori. Ada yang driven cast, ada yang non-displacement pile tu kita categorize bawah dia tu adalah bore piles, different diameter. Micropile pun duduk bawah non-displacement pile. And then pile pun boleh categorize according to the material. Steel ke, concrete ke, and then shape dia. So itu cara lah untuk membezakan pile-pile dan juga kegunaan yang relevan lah. Okay, this chart is help for you untuk decide lah kat mana kesesuaian pile digunakan. Sama ada precast ke, pre-stress ke, span pile or steel H pile, whatever lah. According to the loads here, skill kalau untuk structural part macam mana, geotechnical part macam mana. So details kat sini you can see lah based on the SPT number ataupun based on the bearing capacity. Okay, untuk this problem, saya lebih fokus kepada pre-stress span pile lah, sebab kalau ikutkan problem tadi tu pun yang ni lebih related to it lah. So size around 250mm to 1000. Dia punya length around 6 meter 9 ataupun 12. Structural capacity 55 ton to 520 ton. Ini concrete grade dia. This is some constructions on sites lah. So mungkin yang distatetkan awal dalam report tu not following to the standard might be due to this one lah, masa-masa kerja-kerja piling tersebut lah. So this is the pre-stress pile. Kalau mention standard, yang ni yang kita boleh refer lah. Okay, why choose span pile versus square piles? Firstly, because of bending resistance, higher axial capacity, better manufacturing quality, able to sustain higher driving stresses, higher tensile capacity, easier to check integrity of pile, and lastly, similar cost as RC square piles. So ini antara advantages dia, faktor untuk pemilihan jenis-jenis pile macam saya sebutlah, pile konkrit ke, pile steel ke, pile bearing ke, pile shaft ke, pile combine ke. So ini antara faktor dia, location and type of structure. Kemudian ground condition ni, kalau tengok kat sini, influence both the choice of pile type and the technique for installing piles. So driven piles cannot be used economically in ground containing borders and where ground heave would be detrimental. Driven piles are preferred for loose water bearing sands and gravel, and the steel H piles suitable for conditions where deep penetration is required in sand and gravel. And besides this one, kita boleh pilih pile according to durability and also cost and to the definitions, load capacity of pile. Load capacity of pile ni, yang ni saya fokus kepada single pile. Sometimes dekat, kalau kita tengok salah satu faktor tu ground conditions lah untuk pemilihan pile. Kalau kata single pile tak boleh nak support bearing capacity of soil dan juga loadings tu, so kita kena pakai pile group lah instead of single pile. Tetapi the concept to analyze the group pile, first we refer as a single pile dahulu lah. So this is the combination pile functions. First is the end-bearing pile at the bottom, and also shaft pile surrounding the pile length. By theoretical, the bearing capacity or the ultimate load of the pile is combinations base resistance QB and also the shaft resistance QS. So the QB is the cross-sectional area base of pile times with the QF plus with the sectional area of the shaft times with the FS. So QF is the bearing capacity of the base and FS is the shearing resistance per unit area. If this case, kalau kata you ada circular pie, so the area of the pie is a pi d square over 4. So in this part, diameter or can be same as B also. And for the area of the shaft is a pi BL. So friction pulse in cohesionless soil. So the applied load is transferred to the surrounding soil mainly through skin friction along the surface of the pulse. So a large part of load is also carried by the pile too. So the skin friction resistance varies mainly with the relative density of the soil and with the shape of the pile. Let's say kita tak pilih combined pile lah, kita just pilih untuk friction pile. So untuk cohesionless soil, this is the conditions that we can opt to. Kalau untuk friction pile in cohesive, it is almost whole load of the pile is transferred to the surrounding soil along the pile surface through skin frictions and only a very small part through the pile too. So, maknanya dekat kalau kita guna friction piles in cohesive soil, automatically semua beban tu ditanggung dekat bahagian keliling shaft tersebut lah. Shaft pile. So for end bearing piles, the pile driven down to a layer with a high bearing capacity, the applied load is transferred from the pile to the surrounding soil mainly through the pile load. Selalunya end bearing capacity ni dia akan mid to the hard stratum lah ataupun high bearing capacity. Okay, ini same formula juga. Ada setengah buku dia punya notation tu lah yang membiasakan the symbol, but it's actually bring to the same meaning. Yang mana ultimate bearing capacity of the pile is a combination between shaft loads dan juga end bearing loads. Okay, FS and FB for cohesive and cohesionless soil. Kalau unit shaft resistance FS tadi tu, remember tadi dalam kita punya formula ni QS sama dengan FS darab dengan AS. So apa dia AS, apa dia FB, boleh refer from this table lah. FS, kalau you ambil data daripada SPT, kita boleh dapatkan FS ni for different soil type as here lah, as shown on this slide. Kalau base resistant FB, kita boleh pakai this kind correlations lah. Okay, masih lagi sama macam shallow foundation, so we need to calculate the allowable pile bearing capacity. Sama ada you calculate separately ataupun you calculate for gross FOS. For example here, the Q allowable untuk shaft dia bagi FOS lain. Kemudian untuk bearing capacity pun FOS pun dia bagi yang berbeza. For example here, untuk dapatkan total Q allowable is a QS bahagi 2 plus dengan QB bahagi 3. Atau you can have the gross Q allowable dengan assumptions that QS untuk FOS untuk QS dan juga QB benda sama. Contohnya Q allowable sama dengan QS campur QB bagi 3. That's the thing lah yang final tanpa kita asingkan lah QS FOS dia apa, QB FOS dia apa. Okay, maximum structural capacity of the pile shall be discounted for these conditions lah. Maknanya untuk some particular case, ini faktor-faktor yang kena ambil kira jugalah bila you calculate the Q allowable. Same thing here, kalau you construct pile on the rock strata, limestone ke, granite ke, hard shale ke, so you have the RQD value, so you can calculate the QA based on this number ataupun this relationship. So also we have the negative skin frictions. So this is the conditions masa bila kita pakai negative skin frictions. Okay, kalau untuk pile structural capacity, micropile, so kalau BS standard, so kita boleh tengok class 3.8, 0.4, 0.3. Untuk bore pile, we can follow this standard as well. So untuk pile structure capacity, these are something formula that you can refer from here. For example, 0.25 times FCU. FCU is a concrete strength characteristic times with the AP, which is area of pile. That's why I said this is the problem soil structure interactions. Maknanya kita calculate pile capacity, we also need to calculate the pile structural capacity. Okay, in the other way, in simple notes untuk pile in cohesive, as shown here. Kemudian untuk cohesionless soil, yang ni, kalau untuk cohesionless soil, you can see that the QB is equal to overburden pressure times with the bearing capacity factor and Q. Meanwhile, for the QS bearing capacity in cohesionless soil, pi in cohesionless soil, so we can calculate from this formula, the tangent delta. The tangent delta ni dia ada some charts or table lah untuk dapatkan the coefficients value. Okay, so this is very simple things to explain how it says on the different lateral pressure, kemudian the settlement, how pile can reduce the settlement itself. Okay, case descriptions, we try to look at the problem here. First of all, the schematic figure that has been reported by these researchers, Wang et al. In 2017, how it is taken back from the site and then they do on the problem on certain dimensions. As you can see here, at the north side of the building is a dump soil from the excavated, and also at the south side is the excavation for underground basement car park. And you can see that it's a 10-meter high of the field is quite very tinggi lah kalau ikutkan kat sini. Kemudian you can see as well the soil strata below the stockpile of the soil. Okay, this is again the plan view of the development area and the locations of the building failure. It is modified from the zoo ETL, meaning that the problem has been studied by many researchers, so in their different approaches. So this person's studied to the part of F, for example, and then came the other group of the researchers continued the study from the first group of researchers. So they gave different perceptions how this case study can be carried out in a different way. So the problem, before start doing the analysis, you have to get the assumptions or understands about the problem. It is hollow concrete pile, PHC, and the overburden pressure exerted near the building from additional lateral pressures from north, excavated stored soil, and south, excavated ground garage of the building. The combined loadings from vertical and horizontal forces, piles are embedded in single layer or two layers of cohesive soil. Piles are embedded in single layer or two layers in cohesionless soil. The static analysis on single pile and group piles, the water table effects, and also the settlement of pile groups. So these are the assumptions can be made before the analysis being carried out by having the informations reported from the news or from any other articles. So the assumptions were put on based on the info given on the article in the article. So these are the important things before the analysis will carry out. As you can see here also, the researchers also given the soil profile at the site area. So the geology is mainly composed of alluvial and marine sediments deposited during the Quaternary period as a result of periodic warm and cold climates and the sea level changes. In general, there are 7 soil layers within the upper 50 meter of soil below the ground surface. So the small sections at the figure at the left side here indicates to you the 7 soil layer, From the top 0 to 5 meter, from the top 0 to 1 meter is a fill, and then 1 meter to 4 meter is a silt clay, followed by silty clay, and the next layer of soil is a soft clay, firm, stiff, silty clay, clayey silt, finally found sand. So the sand was located quite below from the ground surface. It means that the soil is very low in bearing capacity, because we look at from the 0 ground meter to the 30 meter or 33 meter, it all silty clay, and etc. Meaning that the soil is very fine grains and it has low bearing capacity. So the approximately 3.5 meter thick crust is composed mainly of fill and silty clay, which are over-consolidated because of desiccations. So desiccated crust overlies a 10 meter thick soft clay layer, which is followed by 16 meter thick firm stiff silty clay layer. So further down lies clay silt. So underlying this deposit is a fine sand layer. And this is the explanation to this figure on the left side. So the water content typically increased from nearly 30% in the crust to approximately 50% in the soft clay layer, and it decreases gradually to 25 just above the silt layer. So the natural water content of the soft clay is larger than its liquid limit, so the soil exhibits soft and compressible behavior. So the undrained shear strength changes slightly in the range from 20 to 30 kPa for silty or soft soil clay, but increases all the way up to 80 kPa for the silty clay layer underneath. So the groundwater at this site mainly comes from precipitations as well as the nearby Dingpu River, and the periodic surface fluctuates between 0.7 and 0.9 below the ground surface. So all these geological information is telling you the soil characteristic and soil parameters at the site during the failure occurred. So from here, the unique weight at the beginning or at the ground surface is 19, and decreasing by depth and suddenly increase because it's at the 40 meter below ground surface is a fine sand. So the water content also shown to you, it is also increase then decrease. So that is true lah. Maknanya dekat bahagian atas ni, clay ni lagi tinggi kandungan air dia berbanding sand. So vein shear, cone resistance, vein shear strength, cone resistance ni antara benda yang boleh beri you input kepada soil strength parameters lah. Okay, the excavations also given on part of the void ratio and the consolidations index. What we see here is a characteristic of the settlement. Okay, the structural pile features. So just now is on the geological characteristic. So the structural pile features here, the building consists of 11 reinforced concrete shear wall buildings, 10 to 13 story high. And the underground garage is constructed on the southern side of the building, contains 13 levels of apartments above the ground surface. So ini semua maklumat-maklumat pile lah. The pile foundation consisting of 118 pre-stressed high-strength concrete pipe piles supported the superstructure of the building. Okay, the PHC piles were steam cured under a pressure of 1 megapascal at 180 Celsius to improve early strength, allowing for earlier removal time of the forms. So ini pun maklumat penting lah, the installations pile and the information about the pile structure. So each pile was 33 meter long and had an outer diameter of the 400 millimeter and a wall thickness of 80 millimeter. The piles penetrated the clay layer and rested on the fine sand as a bearing stratum. Maknanya kalau ikutkan pile ni tak ada masalah lah, sebab dia dah memang berada pada hard stratum. So kalau kata dia nak fail in part of the bearing capacity, it's impossible lah, as stated in this statement. So the capacity of single pile was designed to be approximately 1,300 kilonewton, and the ground beams were used to connect all the piles. Okay, so dia ada ground beams. And to transfer loads from the superstructure to the piles. The ground beam had cross-sectional dimensions 600 by 700 millimeter. The upper 2 meter of the hollow PHC was filled with reinforced concrete and cast together with the ground beam to enable a robust connection, and hence referred to the reinforced zone in the study. So maknanya yang maklumat ni dikeluarkan based on apa they found from the site lah. Maknanya hollow pile tu diisi dengan konkrit sebagai connections to the ground beam. So that's the reason why they did this one lah. Okay, unless otherwise specified, all information is reported by this researcher from Yin and Zhu. And also what's importance? Okay. Okay, this is all about the structural features. Okay, apa pentingnya maklumat features ni? If they say that they want to do the back analysis to understand the failure mechanism on the collapse building, maklumat-maklumat ni penting sebelum dia mula numerical simulations analysis. So on part the structural features, ini dia punya schematic diagram cross section of the foundations. Dia punya diameter, hollow diameter, inner diameter berapa, external diameter berapa, kemudian steel bar, dia punya positions dia, the size of the steel bar. This is also the design properties of the part. Bending capacity dalam 104, tensile crack, bending moment 63. Strength of the reinforcement 1420 megapascal. So kita kata besar lah, compression strength of the concrete is 80. Pre-stress in concrete 5.3. Maknanya kalau tengok dari segi structural features ni, quite perfect lah kan. Okay, the building number 7 had 13 story. Okay, in Shanghai, the height of one story of residential building is typically about 2.9 meter. So that the total height of the building would have been about 38.74. Ini kira kata Chinese standard lah. In China, residential building with the cast in place reinforced concrete structure, so the pressure exerted on the foundation by the superstructure is typically in the range from 10 to 15 kPa per story. Since no detailed information about the superstructure was available, a pressure of 12 kPa per story has been assumed in this study, implying that the total pressure applied to the foundation by the entire building would be about 156 kPa. So sometimes when related to the numerical simulation, ada maklumat tu tak ada. So tetapi macam mana researchers ni keluar info based on the Chinese standard lah. Okay, untuk layout foundations pula, ini yang dia gambarkan the sites area, the pile positions after collapse, pile inspected using cameras. So it's very tedious lah sebenarnya forensic investigation ni. Kalau betul-betul you came after failure occurred ni, dia nak simply person yang berada di sana lah. Maknanya is very person experts in the area. Kemudian dia ada team yang having different background. Kemudian dia ada instruments, dia ada tool yang boleh bantu dia untuk menyiasat. Because benda dah berlaku kan, kita nak dapat info untuk buat analisis tu maknanya dia perlukan a lot of efforts lah. Okay, ini part of the schematic for the problem. So kalau nampak yang ni lagi jelas lah, building number 7, kemudian kedalaman part, panjang pipe berapa, embedded pipe, kemudian 7 layers of soil from the field, silty clay, and then length of the embankment, kemudian tinggi embankment, first embankment, and then second stage of the embankment. Maknanya bila dia tambak tanah tu bertingkat-tingkat lah kan. So bila dah bertingkat-tingkat maknanya dia bagi additional stresses in vertical, laterally pun increase lah. Dekat bahagian selatan bangunan ni pula tengah ada excavation. Walaupun dia dah ada soil nails, tapi yang failure tu very close to here lah, bukan dekat bahagian tepi sana tu. Okay, the excavations, it shows that the relative locations building number 7 and the excavations at the figure just now. Entire garage took up an area 8,000 meters square. The excavation depth was was 4.6. So the basement was first excavated to 1.8 meter below and below the ground surface using the open cut method at slope 1 to 1.5. Below 1.8 meter, the excavation was supported by composite soil nail wall, which consisted of deep soil mixing wall and 2 rows of soil nails made of the steel tubes. Maknanya dia dah provide precautions lah, and never expected that yang punca tu datang daripada bahagian utara. The soil mixing wall was 0.7 meter thick and 7.2 meter long, giving rise to a penetration depth of 4.4 below the formation level. So the steel tube had an outer diameter of 48 millimeter and a wall thickness of 3 millimeter. The upper and lower rows of soil nails were 9 and 6 in length, respectively, and were installed at downward angle of 15 degrees from the horizontal directions. So if you have details, I mean that if you go through the article and read through, they didn't tell us about the failure occurred at the returning wall or soil nailing here. And obviously, they said the causes of the problem, as I mentioned earlier, heavy rain and then differential pressure. So this is the excavations of the underground garage at the south side. Prior to the accident, the superstructure building number 7 already been built during excavation of underground garage. The building suddenly collapsed and tipped over onto the excavations on the southern side. So the western part of the underground garage had been excavated to the formation level. A plain concrete layer had been completed in this area, but the structural reinforced concrete slab had not been cast. Zone 2 had yet to be excavated. After the collapse, the building lay on top of the excavation, although the superstructure remained almost intact. So all these explanations actually came from these figures lah sebenarnya, the explanation yang just now lah, dekat excavation, underground garage and etc. Okay, ini bahagian dump site pula. Tadi dia cerita pasal retaining wall, kemudian underground garage and dekat dump site ataupun dump site. Dalam this section untuk dump site ni, because this is the causes or the triggering point berlakunya collapse. So according to the construction log, maksudnya record yang mereka ada lah. The dumping process can be broadly divided into 2 stages and schematically shown in the figure. Maknanya dia dump bertingkat lah. A large amount of spoil was dumped northern side of the building, forming 4 meter high field slope, approximately 16 meter away from the building. So this is as shown. Kemudian pada June 20, dia buat sekali lagi excavation. Garage began on the southern side of the building. The excavated soil was dumped on top of the previously formed 4 meter field slope and the northern side of the building. And the field slope had grown to approximately 90 meter in length and 40 meter in plane and stood up 10 meter tall. So the vertical loading from the trapezoidal dump soil was equivalent to uniformly distributed loading of 94 kPa. Assuming that the unit weight of the dump soil was 16.5, so the size of the field slope was measured after the collapse of the building. Because of 10 meter thick soft stratum lies beneath the stiff crust, the soft clay could have lost its bearing capacity because of the surcharge loading imposed by dump soil. Based on the undrained assumptions, the bearing capacity of the soil clay was estimated to be 5.14 times undrained shear strength, which equal to 120 kPa. So actually, 1.54 ni is what we call it the bearing capacity factor NC. So benda yang sama kita jumpa dalam shallow foundations. Maknanya dia menggunakan the standard NC for clay, where SU is an undrained shear strength being equal to 25. How they get it? They get it from the vein shear test. So vein shear test ni dapat daripada artikel tu untuk figure number 2 yang mana it taken at the 10 meter with the average 25 kPa. So the simplicity, the weight of the fields and city clay layers above was also considered to be a surcharge loading, which was estimated to approximately 63 kPa. Under this circumstance, the total stress exerted on the soft clay stratum was approximately 157 kPa, exceeding the estimated bearing capacity. Hence, the soil clay layer had likely lost its bearing capacity. So for for this here, we can see that the ultimate bearing capacity of the pile, let's say kita calculate untuk CNC saja, so kita dapat 129 kPa lah. So strength pula 157. So you can see that maknanya 157 ni lagi besar lah ataupun keupayaan tanah tu untuk tanggung. Oh, sorry, 129 tu actually less than daripada 157. Tapi nak katanya the pile capacity tu sebenarnya dia lagi kecil daripada tekanan ataupun yang dikenakan bearing capacity yang dikenakan oleh tanah. So 129 less than 157 kPa. So resulted to the pile fail lah. So the analysis, analysis ni I think that I have. Boleh continue ke atau kita postpone next week? Analysis ni dia bersambung daripada case description lah ataupun daripada this side. Maknanya the intro to have details analysis. On this part is actually showing to you the simple calculations on the pile capacity yang mana kita just take it for the end bearing pile saja. Q ultimate sama dengan end bearing pile QB which is CNC. So for detail analysis ni, kalau you nampak sini how the analysis was carried out from the information from the field investigations, and then the numerical analysis, and also some method to simulate the process of excavations and dumping. I think that I hold this one to the next week because it's very detailed to explain on these three things. Any questions before we end our lecture tonight? Okay, if there is no questions, I'll see you next week class. We continue on part of the analysis in the chapter 3 as well. Okay, Doctor, thank you.
Thank you, Doctor.
Thank you. Bye, Sam.
Terima kasih,
Have a nice
Doktor.
weekend.
Malam. Okay, Doktor. Terima kasih. Assalamualaikum.
Thank you, Doctor.
Salam.
Selamat malam.